Hello everyone. In this video lecture, we'll be learning about the two important ICs and especially an introduction to input-output interfacing module. So this input-output interfacing module, its ultimate focus is to improve the input-output operations in computer system. Okay, so normally when we want to activate any operation, we'll be installing a software called as driver software. That is the one that enables that activates the hardware. So in this fourth module, already we have seen 8279 keyboard display controller, and in this video we will be learning about 8255, that is programmable peripheral interface. Okay, so how do you connect the peripheral device with the microprocessor, and then universal synchronous and asynchronous receiver transmitter, okay, to transmit the data between the both microprocessor and as well as the peripheral devices in both synchronous and asynchronous mode. Okay, and also 8279 chip that mainly focuses on keyboard display controller, and 8254 is timer. Okay, so mainly how these chips can be used in order to introduce uh, the hardware delay, okay, or count events based upon the clock pulse. So, this programming of integrated circuits. Okay, so why we need to have these? Mainly, we see that the microprocessor cannot operate alone, so they do require the input and output devices, such as the keyboard, printers, or any sensors that are connected to the system. So, in order to communicate with these devices, we need to require these ICs are used. Okay, so make sure this is the purpose. Okay, so why we need to have this integrated circuit. Okay, so for this interfacing only, we'll be like focusing on all these 8255 and 8251, 8279, 8254, and these are all the ICs that have been designed to interface with 8285 and 8085 and 8086 microprocessor. So first our focus will be on 8255 programmable peripheral interface. So how do we use these IC in order to interface with 8085 and 8086 microprocessor? So if you take, this is a diagrammatic representation of 8254, and this is a programmable device, okay, that helps to interface, that is connect the peripheral device with the microprocessor, and totally 40 pins are there, okay, and out of the 40 pins, 24 pins, okay, they are the programmable input output pins. Okay, so these 24 pins mainly it focuses on how, say for example, if you take certain protocol like TCP, will listen to the port number 80, okay, and and UDP will listen to the port number 20, and there will be a default port number for each and every protocol. Okay, so likewise 24 pins, okay, they are the pins that are used for connecting, okay, so the devices with the network. So for that, these all these 24 pins, which is organized into different ports, port A, port B, and port C. Okay, so 8 bits for port A, okay, and the next 8 bits for port B, and the next 8 bits for port C. Okay, and this port C itself is divided into two different sets, that is the lower and the upper part. And the lower part will have just the four pins, that is PC not till PC3, okay, PC 0, 1, 2, and 3. And this upper part will have PC4 to PC7. And this is the block architecture of 8255 peripheral interface. So now we have seen these 24 pins. They are organized into two different groups. Okay, so that is group A and group B, and group A will have port A, okay, which is numbered from PA0 to PA7 for 8 bits, and here is where the peripheral devices are connected. And this group A also it includes the upper part of port C, okay, which includes PC4 to PC7, okay, 4, 5, 6, and 7. Okay, and the next group has port B, and which includes the pins from PB0 to PB7, and the lower port, okay, that is PC0 to PC3. And this is the entire control. Okay, and group A control is the main control that is used for the data communication between the peripheral devices. Here all the peripheral devices, and here we have the microprocessor. Okay, and we see that the data bus buffer mainly to temporarily store the data that is transmitted between this chip and the microprocessor. And this bus is a bidirectional data bus to enable the data flow in both the direction. Okay, and apart from that, we have plus 5 volts for in order to provide the power supply for the IC, and ground. This ensures that the stable flow of current. So D0 to D7 for data bus, and RD bar when it is 0, we see that it performs some read operation from the chip. Okay, and WR active loop. So when WR bar is 0, we see that perform write operation into 8255, and A0 and A1 that helps for mode selection. Okay, so whether it wants to function in mode 0, mode 1, or mode 2. Okay, and reset is once all the operation is completed, we have to reset the chip, and chip select is to activate to enable the circuit. This is about the 8255, and here is the explanation which we can go through the explanation what I have given. So now what are all the different modes of operation? So the first is 8255. It operates in three different modes. The first is mode 0, that is basic input output mode. Okay, so which is like taking an input and giving an output. So say for example when we switch on a light, okay, we see that it is able to the light is able to glow. Okay, so when you like give a switch on a switch, then we see that LED glows. So this is a simple input output operation. There is no handshaking. Okay, so in the sense that no connection need to be established, no acknowledgement have to be sent. Again, the ports they do operate independently. So the examples are LED control and reading switches. And mode 1 is strobe input output mode, which uses some handshaking signals. So we see that there should be a perfect synchronization should be done between the CPU and the device. So first it sends an message. Okay, so whether you are ready for data transfer. So in case if it is ready, it sends a message and acknowledgement, and especially for printers and keyboard. So especially whenever a connection is first established in printer. So we see that it is able to continuously print some documents. So this is mode 1 operation, and mode 2 is bidirectional mode where this activates only port A, okay, and port B and C is not activated. So this is where we see that the data transfer takes place in both the direction. So for example, when you want to do this network connection, okay, and when you want a high amount of data should be transferred, okay, so and also in a bidirectional way, then it operates in mode 2, okay, which is bidirectional. So these are all the different modes of operation for 8255, and this is the pin diagram, okay, which includes some. You can see that PA0 to PA7, and you can see PA0, 1, 2, 3, 4, 5, 6, 7, and these are all the pins of port A. Okay, and you can see that PB0, 1, 2, 3, 4, 5, 6, and 7. And these are all the pins of port B. Okay, and the 8 pins of port C is here, which we have continuously PC0 1, 2, 3, 4, 5, 6, and 7. Okay, and apart from that, we have reset and active low. Okay, that is write in order to perform write operation into the chip, and RD to perform read operation from the chip, and CS is chip select to activate the chip, and A0 and A1, they are the address pins. Okay, so these are all again the explanation about the few important lines. Okay, so what is PA0 to PA7, which is 8-bit input output port that is used for data transfer, and then PB0 to PB7, which is another 8-bit input output port for the peripheral communication. And this port C alone is divided into upper and lower. Okay, so 4 bits for upper and another 4 bits for lower. So these are all some of the operations. So now we see that the mode in which the chip has to function. Okay, so how do we select? It is based upon the address lines A0 and A1. So when both the values are 0, port A is selected. When it is 0, 1, port B will be activated 1, 0. In that case, port C will be activated when both the values are 1, 1, and control register will be activated. So when none of the operation is not performed, so we see that the chip is not selected. Okay, and we have this 8-bit control word. So control word, what are all the operations that it has to configure? Okay, so and already we have told that group A is the pins of port A and the upper pins of port C, and group B comprises of port B and the lower pins of port C. And port A, when this can be programmed to work in 3 modes, that is mode 0, 1, and 2. And port B is programmed in mode 0 and mode 1. And port C is programmed to work function only in mode 0. So this is the 8-bit control word, that is D0 to D7. So how this D0 to D7 is configured? Okay, so when we see that D0 bit, when it is set to 1, okay, so we see that the chip will receive the input from the peripheral device, and when the same is set to 0, we see that it will send the output to the peripheral device. Okay, and when D1, okay, so at this time we see that the port B alone will be activated. When it is set to 1, it will receive the input from the peripheral device through port B. Then it is 0, it will send the output to the peripheral device through the same port. And D2 bit, that helps for mode selection. When it is 0, we see that mode 0 will be active. When it is 1, then mode 1 will be active. And the next comes to the group B. Okay, so group A is D3 bit. So D3 bit, we see that when it is 1, we see that at any one of the pin of port C will be activated, and the same chip will function as an input. When it is 0, it will function as an output. And D4 bit also, it focuses on port A. When it is 1, it receives the input from the peripheral device. When it is 0, it sends the output to the peripheral device. And the next is the mode selection is D5 and D6. Mode can be 0. If it is 0, 0, mode 0 is selected, 0, 1, then mode 1 is selected, and 1 followed by 0 or 1 followed by 1. In that case, mode 2 will be activated. Okay, and the last D7 bit. Okay, so D7 bit, it is mainly it is used for um, mode set flag. Okay, so when it is 1 means we see that it will be active. Okay, so you can see that when D7 is equal to 1, in that case input output mode will be active. So in that case 8255 will work as an programmable I/O device, and for all the three ports will be configured as either input or output. Okay, so when it is set to 1, and the same when it is set to 0. Okay, that is the full form for when it is 0 is BSR mode. Okay, at that time BSR mode will be active, which means that which is either bit set or reset for port C. Okay, so at this time only port C is used. Okay, so we can either set, okay, or we can reset the individual bits of port C. So this is about this 8255 programmable IC, and all these explanation which is given here, which you can go through it. So now coming on to the last part, so which is the applications of this 8255. Okay, so 8255 can be used to activate the switches to make the LED glow. So these are all some of the applications of 8255 programmable chip. So make sure that you are able to understand and learn this concept. So if you have any doubts, you can ask.